Okay, 7.6. We are in the final episode of Season 7 here. We're looking at double angle identities. I know it sounds exciting. Double. That means two of them. We're doing a 2x in the brackets. So let's get started here. Let's look what would work, what doesn't work. Let's go and talk about some log laws, just to remind you of those right now. Well, is this first one an identity? Log 2x, does that equal 2 log x? Well, let's plug in some numbers and see. Let's just make it easier on ourselves. Let's make x equal to 10. So this is saying the log of 2x, which is 20, does that equal 2 times log of 10? Well, 2 times log of 10, log base 10 of 10, that's 1. This is 2 times 1, that's 2. Is the log of 20 equal to 2? Well, if we punch that into our calculators, log of 20, nope. That's equaling 1.3010 dot dot dot. That most definitely is not an identity. Doesn't work. Let's check the next one. Is this an identity that works? Well, 2 log x. Let's again use x of 10. 2 log of 10. Does that equal log of 10 squared? Log of 10, we already know that was 1, so that's 2 times 1. 10 squared, that's log of 100. 2 times 1, that's 2. Log base 10 of 100. We're saying to ourselves, hey, 10 to the what equals 100? Oh, 10 to the 2 equals 100. Oh yeah, that equals 2. Or you could punch into your calculator, log of 100, that equals. So that is an identity because it works. And it would work for everything. Just remember, verifying that it's working only means it actually worked for 10. Same thing with when we do this one. Let's check this out. Sine of 2x, is that the same as 2 sine of x? Well, let's try that out. Let's use, we're not going to use 10. Let's use one of our special triangle, our unit circle values. Let's use pi over 4. Let's check it out with that. So we're saying now, sine of 2 times pi over 4, does that equal 2 sine of pi over 4? 2 times pi over 4. That's double of them. Hey, that's sine of pi over 2. Does that equal doubling the sine of pi over 4? Let's hit our unit circle. Sine of pi over 2. We're talking about up here. Oh, that's 1. 2 times the sine of pi over 4. That was over here. And sine, that's root 2 over 2. Does 1 equal root 2? No. That is not an identity. Again, we kind of should have been able to say, yeah, that kind of makes sense. If we're looking at y equals sine of 2x, that 2 right there, that's a horizontal stretch by a factor of 1/2. Hopefully you can visualize what that would look like. The other side is saying y equals 2 sine of x. Hey, that's a vertical stretch by a factor of 2. The horizontal stretch by a factor of 1/2 means that our period equals 2 pi over the b. Our period went from 2 pi to pi. And our amplitude is equal to 1. That's going to look very different than the second one, where that 2 is an amplitude of 2, and the period equals 2 pi over 1, which is 2 pi. Very different graphs. So no, for sure, that's a no-go. This next, construct your understanding. This is really developing the formulas that are going to work. Sine of 2 theta. Well, let's use 7.5, the sum identities. We're going to use our sum identities to develop these. So sine of 2 theta. That's the same thing as saying the sine of theta plus theta. That's 2 theta. Hey, we've got an identity that we could work with that. That's meaning sine of alpha plus beta equals sine of alpha cos of beta plus cos of alpha sine of beta. Run out of room there. Sorry. Let's plug it into that formula. It's right on your formula sheet. We got alpha being theta and beta also being theta. Woo! Let's just slap it in there. Sine of theta, cos of the beta is also theta, plus cos of the theta, sine of theta. So this is saying here sine of theta, cos of theta, plus, this is also sine of theta, cos of theta. I just rearranged the cos and sine, multiply in any order. I've got 1, 2 of the same things. 2 sine theta, cos theta. There's your first identity. Let's go to cosine now. Before I go, I'm going to verify. I'll just verify just this one. Let's use 2 pi over 3. Let's go with theta equal 2 pi over 3, and we're going to verify that this is true. Sine of 2 times 2 pi over 3. Let's see if that's going to equal 2 times sine of 2 pi over 3 cos of 2 pi over 3. Let's check her out. Left side, that's going to give us the sine of 4 pi over 3 equals 2 sine 2 pi over 3 cos 2 pi over 3. And now we hit our unit circle. Sine 4 pi over 3. That's negative root 3 over 2. Boom. 2 times sine of 2 pi over 3. Unit circle. Root 3 over 2. Cos 2 pi over 3. Hey, that's negative 1/2. Looky here. 2 times 1/2. That's going to cancel off. I've got negative root 3 over 2 equaling, we got the negative here. Yeah, negative root 3 over 2. Yeah, left side equals right side. That one is good to go. All right, time for the cosine now. Same process. Cos of 2 theta, that's the same as cos of theta plus theta. Let's just use our formula. Cos of alpha plus beta was equal to cos alpha, cos beta, minus sine alpha, sine beta. Almost made it in space. Well, let's fill her in. This time, my alpha is theta and my beta is theta again. So we got cos of theta, minus sine of theta, sine of theta. Cos theta, hey. That's cos squared theta. Sine theta, minus sine squared of theta. So cos 2 theta equals cos squared theta minus sine squared theta. You could pick any value. You could verify this one. It's going to work out again. I'm not going to verify this. Just be careful with this. This is not cos squared plus sine squared. Cos squared plus sine squared equals 1. Cos squared minus sine squared equals cos 2 theta. And last one here, tan. Same thing. Tan 2 theta equals tan of theta plus theta. And the formula we're using for this one, tan of alpha plus beta equals, right from your formula sheet, tan alpha plus tan beta over 1 minus tan alpha tan beta. In this case, again, the alpha and the beta are just both the same value. Plug her in. Tan theta plus tan theta over 1 minus tan theta tan theta. Clean it up. Tan plus tan, hey, that's 2 tan theta. Tan times tan, 1 minus tan squared theta. And there you've got your final one. And all of these are on your formula sheet, these three. And just remember, we've got to be able to adjust things. That's what's on your formula sheet. But we know using our Pythagorean identities that we can adjust and change sine squared into that, which gives us a new, as we work it through, a new identity. You got to be able to use that one as well. You got to be able to make it on the fly. It's not on your formula sheet. This one's also on the formula sheet, but we're going to change cosine this time and clean it up, and you get another one that's not on your formula sheet. Good idea to write it down, to know how to use it, or to be able to make it when you need. And this is what's on your formula sheet right there. Those three, and then those two you got to be able to make and use. Oh, my bad. I just looked at the formula sheet. You got those two. Oh, lucky you. You don't even have to make them. And let's just use them now here. Okay, we're standard position. We're in quadrant 4, and cosine is 2/5. That means we got x over r. Let's do a quick sketch so we can see what we're talking about. Quadrant 4. X is 2, r is 5. All right, we want to know, in order to be able to do sine, we need the y value. Let's find that y value. And Pythagorean theorem says 2 squared is 4, 5 squared, 25, 25 minus the 4, 21 squared, 21, hey, squared 21 negative. I'm not going to write it down. I just used mental math there. Okay, let's do our sine of 2 theta now. Sine of 2 theta. I don't even know what that angle is, but I'm able to find the value by using our formula. 2 sine theta cos theta. Plug her in. 2 times the sine of this y over r. So we've got negative root 21 over 5. And the cos theta, hey, I already know what that was, 2/5. They told me in the question. Now let's clean it up. 2 times 2, that gives me 4. There's a negative, so negative 4 root 21. 5 times 5, 25. Done. There's my answer. The exact value. Cos of 2 theta. Again, same process. Okay, we know we're talking about the same triangle there. So we're just using the other formula. 2 theta is equal to, we could either use cos squared theta minus sine squared theta, or looking down a little bit further on your formula sheet, we could use 2 cos squared theta minus 1, or we could be using 1 minus 2 sine squared theta. Look at what they gave you. They gave you cosine. Why do we want to start bringing in sine into the situation when we could do this whole thing just with the cosine value? That's the one I'm going to choose. I'm not going to choose the other two. Going to make it easy on myself. 2 cos, that's 2/5 squared minus 1. Working that through, that gives me 2 times 4 25ths minus 1. That gives me 8 25ths minus 1. Subtract 1 off of that, that gives me negative 17/25. Didn't need the sign this time. So a question like this, you could have gotten away with just worrying about the x and the r. You didn't need to find the y this time. Okay, so they ask you, write it as a single trig ratio. They're saying, identify which formula on the formula sheet does this most represent. Oh, that looks like cos squared minus sine squared. Oh, that's cos 2 theta. Okay, well, there's my theta. It's pi over 4. Okay, well, work it through. So then that's cos of 2 times pi over 4, which gives us cos of pi over 2. Cos of pi over 2, hey, I know what that is. That's 0. They asked for single ratio and evaluate. Next one there. Again, look at your formula sheet. Which one does this most represent? It looks a little bit similar to this one. Tan 2 theta is equal to 2 tan theta over 1 minus tan squared theta. But, whoa, this is not exactly the same. And that's why I say look for what's most similar. How can I turn one into the other? So the first thing that we have to do is we're going to try to change this. I can do that by factoring out a negative. 2 tan theta over negative 1 plus tan squared theta. That's going to give me negative 2 tan theta over tan squared theta minus 1. Okay, now that looks the same. But I've got this thing kicking it in front. So that means that I'm going to just take that negative and move it to the other side of that equation there and say negative 2 tan theta, where theta is equal to pi over 6. Okay, so negative tan of 2, and we said pi over 6 was our number. So negative tan of pi over 3. That's our first part. That's our ratio. And now hit our unit circle. Tan of pi over 3. That's root 3, but I've got a negative in front of it. There's my value. Everyone's favorite, prove it. Prove that that's true. Okay, we'll go left side, right side. Left side, I got cotangent theta. That looks like I'm probably not going to have to touch that. Let's work right side right now. The left side had no 2 theta. The right side has 2 thetas. Let's use our formulas to change the 2 thetas out. Let's swap them out here now. So we know that cos of 2 theta, hey, that's equal to 2 cos squared theta minus 1 plus 1. Sine 2 theta, that's 2 sine theta cos theta. And now you might use one of the other ones on the formula sheet for that numerator. Work it through. If you can't get it to work, try one of the other ones. It's like a game. Got to see, do I go down the right path? Keeping it going here, 2 cos squared theta. The ones cancel off, minus 1, positive 1. And I've got, 2 sine theta, cos theta. Oh, those 2's cancel off. And oh, look at that. Also, one of the cosines cancel off. And I get left with cos theta over sine theta. Oh, hey, that's cotangent theta. I got my left side equal to my right side. You could have also said cotangent, that's cos over sine. Perfectly good. Let's work B now. I'm always going to start working the side that has the 2 theta when the other side doesn't. So I'm going to start working left side right now. And hopefully I can get it to equal the right side, or else I'm going to have to do some work on the right side as well. Let's try our left side. I'm going to change everything to sines and cosines just to make it easier here for me. That's cos theta over sine theta multiplied by 1 over sine 2 theta. You cannot combine sine theta and sine 2 theta together. They are not the same angle. But we can use our formula sheet. Sine 2 theta, that's 2 sine theta cos theta. And boom, boom. We're left with 1 over 2 sine squared theta. Oh, look at that. Left side equals right side. Boom. And if you haven't noticed, we always finish off number 4 with, let's bring it into last chapter. Let's solve now. You've got sine, you've got cos, you've got 2x, you've got x. We got so much stuff going on here. We're going to have to change one to the other. We don't want to change the x. We always want to change the 2x into the x. That's the one we have a formula for. That's our starting point. Sine 2x. That's 2 sine x cos x minus cos squared x equals 0. Let's clean it up. Those two are going to cancel each other off. We're just going to get left with sine x cos x minus cos squared x equals 0. We equate to 0 and we factor. We've got a quadratic there. Equate to 0 and factor every time. It is equated to 0. Now we factor. First step of factoring, GCF. Pull out that cos x. Leaves us with sine x minus cos x equals 0. We're looking at two places now. First place we're looking, where cos x equals 0. And we also have where sine x minus cos x equals 0. Well, that's going to happen where sine x equals cos x. Well, I can look at where that's going to happen, or let's divide both sides by cos just for now, just so that we can get, you could also look at this as being tan of x equal to 1. Now, by doing so, by looking at tan of x equal to 1, I am bringing in, at this point, a restriction because I put a denominator there. I have to be very careful that that restriction is not going to be one of my spots. If it is, I have to go through and adjust that. So the way I do this check is, right here I'm saying cos of x cannot be equal to 0 in this part of the equation. It can over here. I'm good over on the left side question. On this right side, is this going to affect the sine value? When cos of x is 0, is it equal to sine? No. When cos of x is 0, sine of x equals 1. Those are not the same. So this restriction that I just brought in is going to be okay. I can look at dividing over the cos and using tan in this case. Just be careful that if you ever make your own denominator, that you are not dividing out a solution. So over on the left side, I've got cos of x equaling 0. I'm going to work through that one. That means that x is either equal to pi over 2 or 3 pi over 2. Again, that's just in your unit circle spots. Tan equal to 1. That's where the x and the y are equal. Or you could have right from here said, from the unit circle, where are the x and the y coordinate points the same? Because where's sine and cosine the same? Either way, that's going to happen here or there, which is pi over 4 and 5 pi over 4. So there's your answer. Let's bring them together into one. We've got pi over 4, pi over 2, 5 pi over 4, 3 pi over 2. I just put them in the order. And this was domain from 0 to 2 pi. Always check. I cannot use 2 pi. All right, and finish off for yourself. There's your 3 questions to bring it together for you.